This is the first video for section 1.6, the second derivative. But this video is actually going to be about the first derivative. So we'll get to the second derivative in the second video. So what do we know so far about the derivative? We know that f prime of x tells us the slope of the tangent line to the graph of f at the point x. And our ultimate question in this section is, what information can we get about f of x from how f prime of x is changing? In other words, what information can we get from the derivative of f prime of x? But first, let's see what information we can get just from the derivative f prime. So we'll say that a function f of x is increasing on the interval from a to b if for all x and y in that interval, if x is less than y, then f of x is less than f of y. So what's that saying? As I move from left to right, my function values get bigger. So here is an interval from a to b. Notice x is smaller than y. And I want my function values to be getting bigger as I move from left to right. So here for my arbitrary choice of x and y, notice f of x is less than f of y. So an increasing function gets bigger as we move from left to right. On the other hand, we say that a function f of x is decreasing if for all x in the interval from a to b, and you might guess, if x is less than y, we want f of x to be bigger than f of y. So in other words, as I move from left to right, I want my function values to get smaller. So here's my interval again. X and y are between a and b. X is less than y. And then notice I want f of x to be bigger than f of y. So my function is getting smaller as I move from left to right. That's a decreasing function. So here's a theorem. This relates the first derivative to whether a function is increasing, decreasing, or neither. So we're going to suppose that we actually have a derivative at a point a. So we're going to let f be a differentiable function at a. Then the function f is increasing at a if and only if the derivative at a is positive. The function is decreasing at a if and only if the derivative at a is less than 0. And if the derivative at a is equal to 0, we say that f is neither increasing nor decreasing. So let's just sort of convince ourselves that these statements are true by looking at some pictures. So here is an example of a function that is increasing at a. Now notice if I draw the tangent line at a, the slope of that tangent line is positive. Well, the slope of the tangent line is, in fact, the derivative, so that means the derivative is positive. And notice if I had a function, I could go the other way. If I had a function whose tangent line had a positive slope, then that would be an increasing function. On the other hand, if I draw a decreasing function at a, and again I draw the tangent line, notice that the slope of that tangent line is going to be negative. So since slope of tangent line is f prime of a, that means a decreasing function is equivalent to the derivative being negative, assuming the derivative exists. And finally, what does it look like if a function has the derivative at a point being equal to 0? Well, that means we have a sort of point where the function is not changing. So we have a point where there's a horizontal tangent line. And we'll say that at that point, f is neither increasing nor decreasing. So the sort of to sum up this first video, the graph of f prime of x tells us where f is increasing or decreasing or neither increasing nor decreasing. In the next video, we'll see what the derivative of f will tell us about the function f.